So this is 9.4. This is figure 9.4. Yes. So you are supposed to simulate this in the LT Spice, and we need to find we need to find IS, I1, and I2. There is no I3, you don't have to find, and you have to do table 9.5. So table 9.5 asks you to find currents. So I2 is equal to I3. You can just write it like that as well in table 9.5. So here we just have the calculated value and the simulated value. So in the table for now, you can just write it like that. And the other thing is, okay, so once you record I1, I2, and I3, you need to mention that I2 and I3, how they are related. What do you think? Why they are similar, or if not, what is happening? So you just need to do that. Measure the voltage V1, V2, and V3. V1, V2, and V3, you need to measure means that here we will have just the simulated value. And another resistor 4.7 kilo ohms in loop 1. Like here, you need to add another resistor that is 4.7 kilo ohms in loop 1, and then you need to find out. Okay, so one more thing is that when this is asking you to calculate these currents, there are multiple ways of calculating it, right? Either you take 12 volts here, like this 12 volts at this node, and use Ohm's law to calculate the currents, because you have the voltage and you have the resistors, or you can, I think Ohm's law would be the best here to calculate the currents. Okay, and anything else? I think 9.5, and then measure the voltage and write in table 9.6. So that's what we need to do in this circuit. Now the difference of this circuit with the other circuit is actually that they have here you have the two resistors that are in series, and there are one resistor that is in parallel. So you have series and parallel combinations both. Another way of finding, in this case, another way of finding IS is that you calculate the equivalent resistance and use the Ohm law, then finding the IS current. You can also do that. So it's up to you what method you want to use for the calculation. So in this circuit, you have to answer a few questions. How is the total voltage across the two resistors, element R1 and R2, related to the applied voltage, and why? Okay. Calculate the equivalent resistance, compare it with the resistance calculated using Ohm's law, right? So you can calculate the equivalent resistance, RT, and then you can check that this equivalent resistance is equal to your Ohm's law resistance. Your Ohm law resistance is like the equivalent resistance using Ohm law will be E over IS, right? So, and the other form of resistance you can calculate, like this equivalent resistance, is by this calculating the parallel combination, series parallel combination of resistances, and that you can find out your resistance. Then calculate the voltage V2 and V4. Okay, so this is your V2, and then you will have V4 that may be here after adding the resistance. Using the voltage divider. This is not the voltage divided rule. I think this is talking about V2 and V3 here. And measure resistor values, insert the results in table 9.7. Yes. So you can add your results in table 9.7. So this should be V3. So these three questions you will answer after adding 4.7 kiloohms. Okay. Okay. Then this second part is, in the second part, you need to construct another circuit, that is figure 9.6. And in this circuit, the difference is that you have some resistance on the path of IS2. So there will be another voltage drop. So this E, 20 volts, is not equals to this E, right? Here. So E is not equal to the voltage at node A, let's say. Calculate the voltage V4 using Ohm's law and compare it with simulated and value, and insert the results in table 9.8. Okay. And then find simulated current IS and calculate the total input resistance from Ohm's law, record both in table 8. Okay. First, you need to calculate V4. So V4 you can calculate by, so you have 20 volts here. You don't know IS. So how you can calculate V4? What do you think? Either, there are two ways. Either you will find the series and parallel combination of these resistors, that you will find like these two are in series at first, then you will find the parallel combination with this resistor, and then you will find the series combination of this resistor, okay? The R equivalent will give you IS. E over R equivalent will give you IS. Then what you can do is, once you have IS, you can find out this voltage drop here, which will be VR1 which will be IS R1. Now your VA will be E minus VR1, right? So once you have your VA, you can find this current and this current. So your, let's say this current I2 here is what do you think I2 is? What do you think? What would be your I2? This is your I2, like the loop, this and this loop. So your I2 will be 4.7 VA divided by 4.7 plus 3.3. So once you have your I2, you can find your V4, right? So V4 will be What will be your V4 if you have I2? Can you hear me? Can you hear me?
Yeah, we
Yes.
can.
Okay, so what do you think V4 is? V4 is R4 multiplied by I2.
I2?
Yeah, okay. Or you can also find V4 by voltage divider rule by putting R4 divided by R3 by R3 plus R4 multiplied by VA. Another point of, because these two resistors are in series. So first, when you look at the circuit, you need to see whether, how can I simplify the circuit, okay? If they ask you to calculate things. So this circuit can be simplified by looking at it that these two resistors are in series. Then the equivalent of these two resistors will be in parallel with this resistor. And similarly, the equivalent of these, this part here will be in series with this thing. Similarly, in the previous scenario, I actually mentioned here is that R2 and R3 are in series while R1 is parallel to R2 and R3. The purpose of mentioning is that that will help you to calculate your equivalent resistance. Okay. Now you need to calculate your RT, which is the equivalent resistance, and compare it with simulated value of RT. So RT can be calculated as R3 plus R4 because they are in series and they will be in parallel with R2, and this whole thing will be in series with R1. Got it? Is it fine?
Yes.
Okay, so if you replace your R2, if your R2 is very much higher than your R3 and R4, then you need to tell what is happening. You need to see in your simulations too, and you need to explain it too, because now you can explain what is happening if you are increasing this resistance so much. Means that you are squeezing this path, right? So what will happen that, what changes will occur in the circuit that you need to explain. Then what will happen means that what changes will be in the circuit if R3 is short. If your R3 is short, what do you think will change in circuit? Similarly, what will change in circuit if your R2 is short? That these things you need to discuss. Okay? Am I clear about that?
Yep.
Okay, so this is the end of lab 2. Um, um, you will write the report and submit it next week. So this lab 2 is not due today, but this is the remaining 2 parts of lab 2 that I wanted to discuss, and then you will submit it next week, okay? Why I am giving you more time, because I want you to be familiar with the book and how you want to write it and stuff like that, so it's fine. The other thing I saw in your lab reports, I did not grade it yet, but it will be helpful for me if you write the question first and then answer it, because if you just write the answers, I do not know what answer you're writing, okay? So it will be good if you write the question first, like the exercise question, and then answer it. Okay, so let's start lab number 3. I have posted lab number 3 as well. Okay, let me share it. Okay, so in lab number 3, this is the intro lab of the equipment. So all of you got your kit, equipment kit?
Yeah.
Yeah, we did.
And Professor, someone had a question in chat.
Mm-hmm. Oh, okay, I just didn't see that. Just a minute. Yes, lab 3 is also due next week. Because it's not very long, I want you to, you have all week to try it on and write a report. So both labs are due. Yeah. Okay. We will see that if you were not able to finish, I will let you know. But I am supposing that it will be due next week. Okay, so you all got your kits. Keep your kits in front of you. What we will need today will be multimeter. Can you see me?
Yeah.
So we will need multimeter today and resistors and
Which
wires.
resistors?
So this 1K resistor for now. So this 1K resistor and this breadboard you got. You don't have to do this, and then you have this battery, 9-volt battery, and 1.5-volt cells that I have put in. Okay, I'll go through it. You don't have to worry about that. Okay. So first, let's start the lab. So we don't have power supply. Normally when we do labs here, we have the power supply. So what is the objective of this lab? We want to learn about multimeter. We want to see breadboard internal connection. We want to create circuits on a breadboard, DC voltage, current, and resistance using multimeter, electronic component that we use, identify resistor values, and we will calculate resistor values from DC voltage and current measurements. So what is DMM? So this device actually is called digital multimeter. Okay, so this device is used for voltage, current, and resistor measurements. If you see on the voltmeter, you can see that it has the volt sign like DCV, which means that DC volt sign, then DC ampere, and then DC ohmmeter. So how it works, so let's say your circuit has 1 volts in it. So you will move it to the point where you think that it is in the range of 1 volt. Let's say I want to measure 1 volt, so I made it 20. So within 20, I can measure 1 volt. So it is auto range thing, so it can range itself, but I need to make sure that it is within the range of that multimeter. So it can do three measurements like voltage, current, and resistance. So first we need to select that which measurements we want to do. If we want to do ohmmeter measurement, we will move it to the ohmmeter scale. If we want to do voltmeter voltage measurements, we will move it to volts to scale, and similarly for ammeters. Okay. The other thing is the test leads. So these test leads there are 3 circles here. If you can see, there is volt, ohm, milliamps, and 5 ampere DC, and there is a common ground. So the red one is the wire which always go towards the positive volts or ampere side. So we will put, let's say if we want to do voltmeter measurement, it will be in the voltmeter side. And the black is always ground. So it should be go in the COM side. Okay, so that's how you connect it. Okay, the test lead must be connected to your current differently for different kinds of measurements. So, okay, so the other point is that you should read these things because they have the instructions in it. So if it is you, so if you see in the figure 2, you are seeing that how you connect your like this device with the circuit. Let's say if you want to measure the voltage, then it should be connected in parallel with your device under test. Okay, if you are measuring the current, then it should be connected in series. How it should be connected we will show. And if you're measuring the ohm meter or the ohm, like the resistance, then it should be also connected in parallel. So for the current measurements, your sign matters. So if you can see, and similarly for voltage measurements. So if you can see that red sign shows that the higher current and black sign shows the lower current. So if you switch your leads, then it should show you the minus or negative sign. Okay, so with the current measurement, we need to be real careful. We need, every time you are done with your measurement, turn the multimeter off because you can blow its fuse if too much current is flowing through it. Okay. And for the resistor measurements, it doesn't matter. The sign doesn't matter. So you can connect any sides of the lead. Okay, I already talked about it. It's auto-ranging, which means that it automatically changes the measurement units to provide the largest number of usable digits. Okay, so then I am just quickly talking about the components that ENG214 has. So most of the time we will be using resistors. So you can see these resistors, they have some color coding on it. We will talk about them as well, but this is the resistors that we will be using. Then there is a capacitor. So there are all sorts of capacitors. Then they will come in our circuit. Then we will also talk about them. I think we have these 100 microfarad capacitors in the kit. And similarly, you have, so there are some potentiometers. You don't have potentiometer, but they look like this. Potentiometer is the variable resistor that you can change with the knob or this screw. Then there is the inductors. So inductors looks like these. These inductors we don't have for this kit, but they are also there. Okay, so the 9-volt battery connector is the black plastic guy with 2 snap mounted on it. So this is the, okay. So there are 2 types of the batteries we have. There are cell batteries in which you can just put on the cells like you do in other devices. So these are 1.5 volts, so they make 3 volts, right? And then this is, there are 2 wires, black and red. So red is always used for higher ground and black is always used for lower, like the ground. Thank you. Then you have these batteries, 9-volt batteries, and I have already connected them, but one of them is connected. So I just don't want to take it off. so you can just connect it like this. Can you connect it by yourself? You have batteries in front of you?
Yes.
Okay, so do you have any questions? We are good about it? Okay, let's move. Okay, now this is important to know. This is your breadboard, okay? So in your breadboard, if you can see, this is your circuit area. Like here it is showing that this is your circuit area and these are your power lines. Okay, so this is not connected to this one. okay? But you are supposed to provide the positive power in the top thing and the ground in the bottom thing. Similarly for the lower part as well. So they are connected to each other. Another important or the interesting thing is that in the breadboard, these are the short connections, like so these connections are connected to each other, like in the vertical line, and the horizontal lines are not connected to each other. So this looks like the what you should say, the breadboard connections. And so if you have to connect the resistors in series, you know that, can you see this thing, the mouse?
Yes.
Okay. So if you see here that this straight line is connected, right? So this in the series, you need one connection that is common, but not the other two connections that are common. That's why you can put both of them in the same vertical column and they will be considered as connected. And then these two resistors can be at any other place, so they will be not connected. So this is the picture of your breadboard connection on as a series combination of the resistor. Is it clear? Am I clear about that?
Yes.
Okay. So similarly, if you go towards the parallel combination, so in the parallel combination, you need to have both ends to be connected to each other or have the same node. So that's how you connect two nodes here. So you make two nodes here because vertical columns are connected. So that's how you do it. Okay. Okay. Then, okay. So what we are doing here, we will be doing, okay, the connectivity check. Okay. So connectivity check, for the connectivity check. So one more thing is, so you have these wires too, right? And you have these plier too, right? You have it?
Yeah.
There is this lock. You can take it off. And you can connect, or you can cut any size of wire you want. Okay. So let's say I will connect this size, right? And then you need to take a little portion of bare wire off. Where is that? Like this. So from the two sides, you will, using plier, you should take these wires like this. Can you see that? Okay. Is it clear? Can you do that?
Of which gauge wire?
So this is, I am not sure. Let me check. I think you can use it to one, I think it fits in the 1 mm area. Or it's also 0.8 mm will do best for you. Okay. You cut it by putting between them, between two holes, and just take this thing out. Okay, so I have like multiple wires I have here. So for the connectivity check. So I am trying to switch my camera now so that it will be visible for you. I'm going to, okay. So can you see the breadboard now?
Yes.
Right? So this breadboard has, I have connected wires. Let me put some. Mhm. Okay. Okay. So these are the wires I have connected them. So what I need to do, I need to do the connectivity check. So what is the continuity check? So what is continuity check here? So it says see your multimeter on, set your multimeter on resistance. So you need to set this on resistance. Okay. So I set this value on resistance. Turn it on and set it on resistance. So you can see 200, 2000, 20K and 200K. So I set it, let's say on 2000 or 200. Okay. So this is my connection. Another thing, if you can see on your it doesn't have this, I think. Okay, so that's how you connect it, and then now you need to see what is the resistance between two holes in a row of 5 connected holes. Measure and record the resistance between two holes at the opposite angle of long side plus or minus. Explain the difference. What resistance did you measure between the unconnected hole? What did your multimeter read? Does it make difference? So what you need to do, you need to check the resistance between these two holes, in these holes, and between these two holes. Okay, let me check. So if you see my circuit, I actually put 2 wires in these two. So they are not connected to each other, right? Because only the vertical columns are connected. So let me check that resistance in that. So how I will check the resistance? These 2 leads, my leads will be on them. Okay, first let me check the connected one so that you can see what difference it should make. So can you see the resistance when you check the resistance between them? Let me make sure. So what is happening? Let me check it from my other multimeter. I have to just to double check what is going on. So some multimeter give you the deep sound when the circuit is short, okay? But in this multimeter, this option is not here, so it's okay. So what what it shows that when they are connected is that you are seeing some resistance, or you are seeing some value, very small value here, okay, when they are connected to each other. And if you see in this my multimeter, so when I am trying to connect them, not trying to, so I can see some value that is changing in the ohmmeter section. So it shows that they are connected to each other. Can you see that too? Can you do that?
Yeah.
So when you are trying to put your leads on the resistors, you can see your value is changing, right? Now, if you try to move this wire to the horizontal line and see what value you should see. So as they both are not connected, you are not seeing any change, right?
Yeah.
So that's another continuity check, that they are not connected to each other. Similarly, if you move your wire to the power rail, like this one, so right now I am moving it to the one power rail, not the ground section, to just check the continuity. So you can see the values are changing, very small resistance is showing. It means that they are connected to each other. Similarly, if I move my wire to the ground rail and check the difference between positive and negative, then you can see that they are not connected to each other. Okay, so that's another way of checking your continuity, that how you can check your resistance. Okay, am I clear about the continuity check? Can you all do that?
Yeah.
Okay, so this was so every time you've done using it, try to turn it off, and let's do it from there. So have you able to use pliers to cut your wires?
Yes.
Okay. So now we know that what are the resistance, we know, but here we just think that we don't know our resistance, okay? So if you don't know your resistance value, you just need to try to find it. So I'm using 1K resistor, but I will try to find the value of the resistor, okay, in the circuit. So this is like the mystery resistance for me, okay. So this is the 1K. I took this resistor from 1K resistor, okay, packet. You take the resistor from 1K resistor packet, and we need to put it on the breadboard. So on the breadboard, I will just try to put it anywhere like this. So that's how I put the resistor. Okay. Now I need to connect the power, and to connect the power, so you are able to move your legs like that, the resistor legs, and put it in the breadboard. So you should always connect it in the horizontal direction, because these horizontal are not connected to each other. Okay, so we are done with that. Then I am using, instead, I don't know, I cannot use this as 1.45 volts, I think, because it has 2 cells. So I put 2 cells in it, and this is 1.5 volts each battery. So I'm making it with a 3-volt battery, and I will connect it. And you put yourself here in the holder, and you connect it to the positive and the negative thing. Okay, you're able to do that. Am I clear?
No, it's
Okay.
very blurry.
My video is blurry.
Yes.
Now it's clear. Okay. First, I just want you to put the cells in it. Okay, don't connect it yet in the circuit. Just put the cells in it, and or the these batteries in it, and put it aside by the breadboard. And then I want you to put these two wires. One wire is going in the positive power rail, and the other wire is going in the negative power rail. And I want you to connect the negative one to one of the point of this resistor. Once I connect it, and I will show you. And so they are all connected like the positive power rail, so you can connect from any side. But just don't short the positive and negative thing. So can you see this thing? Sorry. So can you see this, what I have done?
Yeah.
So this is connected in the like in the vertical thing, which means that they are connected to each other. The blue line, which is going to the ground, is connected to the one leg of the resistor, and similarly, the red one is connected to the other end of the resistor, right? Am I clear? Should I move?
Yeah, no, you're clear and everything. It's just hard as hell putting these things together.
So you are doing, but it's not working?
I don't know, you're doing it. It's hard to put these things in because keep falling out.
It's okay. Okay, what is in the chat? There is a kink in the spring of my wire. Gillis, can you share your screen or show me what you mean? So you cannot cut the wire? Okay. So you need to do this. Yes. Oh, did you take off the lock? Take off this lock. Yes. Yes. Now. Oh, yeah, that's fine. This is fine. You are mute. I cannot hear. I cannot hear you, Julius. Yes.
There's a kink in the spring, so I can't close it all the way.
Oh.
If you can see it.
Push it really hard.
I'm trying. It just won't
Like,
close.
try to
And I open it and like I tried to fix the spring, but it won't. There's two kinks in it, so it's right here, and I can't close it all the way.
Try. You cannot close this, even this part. Let me change.
Yeah, that's what I've been doing. I've just been scoring it so that I don't cut it all the way through, and then pulling the jacket off.
You cannot use this one, this part?
Yeah,
again?
I can do that one. Yeah, that's what I've been doing.
Yeah,
but
just cut it from there.
And then I scored the jacket so that I can.
And can you show me again and try to, yes, use this one. I think I know. This is,
And then I just let it off. That's what I've been doing for the time being.
okay. Yeah, I can ask what it is. Okay. So, okay, where's my thing? Okay, so this is the circuit I made. I don't know. Can you see that? Okay.
If you hold your hand up behind it, it'll focus on the actual little piece of it. Yeah, like that.
Am I clear? This camera I have, the webcam. Okay, just let me know that, do you made this? Have you made this? Should we move forward? So this wire, the red one, is the power rail. It's connected to the power rail, that's the positive thing, and the blue one is connected to the resistor thing, like the other leg of the resistor. So both of them, you can see this is in the same line, which means that the leg is connected to the power, and the other means that leg is connected to the negative side. Okay. Now I will connect the battery. So I am not connecting the battery first because it can, you know, burn things up. So you should be careful. So now I will connect this 3 volts battery. Okay. This thing. And I will connect it in the circuit. So just be careful when you connect it that positive should go in the positive, and that you don't short the negative thing with the positive, and negative should go in the negative. Okay, so I connected the battery. Am I clear? Are you able to do that?
Yeah.
Okay, so now let me measure from, okay, voltmeter. Okay, so
Are we supposed to install our battery into the circuit?
what?
Are we supposed to like hook up the battery to the circuit too, or just the resistors with the wire?
No, I have connected the battery too. Let me show you.
Okay.
Okay, so this is my battery, 3 volts battery, right? Right?
Okay.
And that's wire is going here. Okay, my camera. So this here. So these 2 wires are coming from that battery, right?
Okay,
So,
I see now.
so the positive is going in the positive and negative is going in the negative, okay? Got it?
Got it.
Okay. Now what I will do, so now what I will do is I will measure the voltage. So this is my multimeter. This is my multimeter. and I will set it up, turn it on, and I will set it up to volts. So let's do it at 20, okay? So I set it up here at 20, DCV, where there is a DCV at 20, and I take my leads like this, okay? And I will put it across the resistor. So when I will put across the resistor like this, like on the legs of the resistor, my positive is going where the positive of battery is coming, and negative is going where the negative of battery is coming. So when I do this, what value can you see on your multimeter?
3.22.
I can see 3.
I see 3.25.
Okay.
Yeah, I'm getting 3.1 or 3.21, 3.22.
Can you check your, so this, when you connect it here, this is on volt ohm, like the red lead, right? It's not on the ampere thing. Just double check it. So the ampere thing means that if you have very large current drawing from the circuit, then you will put it in the 5 ampere above jack, okay? But if your current is small and your voltage is like we are doing, so you will always connect it to the second one, right? I just want to make sure. Okay, so now, yes, so this is the fine. I think I am getting 3 volts or 3.01 or 2.99. So you are getting 3.22 or 3.01, right? Like this, right? So note down this voltage, whatever you are getting across the resistor, okay? So this is the voltage drop that is happening across the resistor when you are applying 3 volts battery to it. So it's fine because that the current is flowing and that's causing that much voltage drop, okay? But you don't know that it's 1K resistor, okay, right now. We want,
do we
yeah?
write this voltage in table 9.6?
Just a minute, let me see. No. This is new lab, okay? So you are not supposed to write the voltage, but just in 9.6. You are just writing the measured voltage here. Make another table for you, okay? So you just write that you have this voltage drop across the resistor RM that is 3 volts, okay? 3.2 or whatever you're getting, okay?
My reading won't stay at just one number. Like it keeps jumping. My reading for voltage, it won't stay the same.
Yeah, it's fine because we are using our hands and they are moving, so it's okay. Okay?
Okay.
But it should be in that scenario, like mine is changing to from 2.8 to 3, something like that, right? But you use the number that is more, you are seeing more.
Okay.
Okay. Okay. So now you know that the voltage is fine. This is the way of measuring the voltage. Take the battery off, like take these wires off so that it may not be connected anymore. Now we will try to measure the current. So you're good with the voltage, right? You all were able to measure the voltage around 3. Okay.
Yeah.
So let me check that how we will measure the current. So to current, for measuring current, we have to do something like this. We don't have another resistor, but we will break the circuit and we will put our multimeter in between. Then we will be able to measure the current, okay? So how we will break the circuit is, and we will break it from the positive side. Okay, so I will take the red wire off and put it somewhere else in my breadboard. So that's how I am breaking the circuit. So I take one side is connected to the power, the other side I took it off and I put it somewhere on the breadboard. Okay. Then I'm taking another wire, the small wire, and put it in the vertical thing of the same line because I want to connect my multimeter here. Okay. Is it clear? Because I'm breaking the circuit now to connect the multimeter, to connect the ammeter. Is it okay? Am I clear? And similarly,
Yeah.
I will take another wire and put it in like the vertical line of the resistor so that I just show how I'll connect this when I'll put the multimeter in. Okay. Am I clear?
Yeah.
Okay. So now I will connect this battery again in the same place where I did before. Okay. And now if you want to see the voltage drop across resistor, there is no voltage drop, right? Because the circuit is disconnected. Now I will move this thing to the ampere scenario where it is 20 milliamps. So I'm moving it to 20 milliamps, okay? Something like that. And I will use my leads. The red one will go to the positive side of the rail and the black one will go to the negative side, and I connect it and you can see some current is flowing. Can you see the current value? I am seeing 2.9 or something like that. What do you see? 2.8. Can you see the current value between these two between these two wires?
Can you show what your multimeter looks like again?
What did you set your multimeter to? Which
I
setting?
moved it to 20 milliamps,
Okay.
which is 20 amp. Oh, it's blurred maybe. I think it shows you opposite, or it's fine for you.
Yeah, that's fine. I'm getting 2.9.
Yes. So this is my multimeter, okay? Who was asking? Nicholas?
Yes.
Okay. So now I set it like that and record the value wherever you are getting. So let's say you were getting 2.9 or 2.8 volts, and then you were getting 2.9 current. So when you will divide voltage divided by current, so you can get the resistor value, right?
Yeah.
So that's how you will try to measure the current. So you have to break the circuit, and if you swap your leads, like if you make your black one on the positive side and the red one on the lower side, then you will see the negative sign, right? If you swap your leads, instead of doing this, you do this, then you will see that negative sign that shows the negative current. And you record the maximum value of current that you have seen. So let's say I have seen here the maximum value of current. .9. Okay, so record that. But what I'm trying to say is that if you swap your leads, can you see the negative sign on the multimeter?
Yeah, we can see it.
Okay, so which means that the negative current is flowing. So we are good about this part. Okay, everyone is clear? If someone is not clear, just let me know. Okay, so let's move.
I got my current as 3.19. Is that wrong?
1 minute. Can I turn it? Yes, go ahead. What you're saying?
The current that I got was 3.19.
No, it's fine.
That's
I mean, just record your values. The maximum that's what you are getting, right?
Yes.
Yeah, it's okay. I mean, just record your values and we will learn why you are getting different values, okay? So, but for now, we need to know how it works. So just take the battery off so it may not burn up your resistor, and take this multimeter off, okay? So now what I need to do is so in this document, I have multiple, instructions or the safety things that you can use to make yourself safe and your equipment safe. So you don't have to connect your battery all the time. Once you are done once you're done measuring your circuit, you just take it off, okay? So, and similarly, you're not supposed to take this on all the time, okay? So now I want you to connect these two batteries in series, okay? How we will do that, we will know. So you can see the negative sign of the 1.5, which is 3 volts we are doing, is connected to the positive sign of 9 volts. And then negative sign is connected like that. So how we will do that, I'll show you. But so this is 9 volts in series with the 3 volts, which makes this 12 volts, okay? So let me have a wire. So what I'm trying to do is I am trying to connect them in series. Too big. This is too small. Okay. Okay. And I have this battery, and I put this cover of that, this plug in. I did the plug in as well, so I have both of them here. So 3 volts and 9 volts, okay? Okay, so I need to connect them in series. What I did first, if you see here, that I actually have the resistor in the same place, and I connected to the positive wire like this to my resistor, okay? And it's going in the positive rail, okay? From the negative side, I took another wire, a little bit bigger, and I put it in the other side, the other power rail's negative side, okay? And then I took the negative of this, like where I was having previously the negative side, and connected to the positive power rail of the other side. It's because of this thing that I have to connect it negative to the positive and then negative back again to my resistor. Okay. So I'm using this power rail as well because this power rail is not connected to this power rail. So am I clear about that? Do you have any questions?
Can you back it up a little bit? Yeah, there.
Hey, a recording of today's lab is gonna be will be up after class, right?
What?
Are you recording? Are you also gonna be recording today's lab and uploading it up to Canvas?
Yes, it is there.
Okay, making sure.
So you got it? Am I clear? What you need, I'm explaining again, okay? What you need to do is this positive wire, you connect it to the one leg of the resistor, this one, that's fine. Now you need to connect this negative rail to the positive rail of the battery, okay? So I am connected to the other side. And then you need to connect this negative wire and connect it to the resistors. Okay, so I'm clear. Should I connect the battery and the things? Okay, I'm trying to connect the battery now. Okay, so I will connect my cells in the same place that we have connected before. That is 3 volt thing. First, you look at this and understand it. If you feel that it's fine, then you try, okay? Let me just quickly verify that it's fine, and then I'll show you. Okay, so what I did, if you see here, okay, and what I did, I used these cells, right, and connect it to the same place that I have connected it before. Okay, like the positive in going positive side and negative going negative side. Then I connect the battery in the other rail and in the same place, like positive going in the positive side and negative going in this negative side. So if I have connected my circuit fine, then I should not bother about the sign, like about that, whether they are connected in the circuit or not. I will just put the positive side in the positive rail, negative side in the negative rail. Similarly, positive side in the positive rail and negative side in the negative rail. Okay, am I clear? Boris, you want to say something? Okay, now I will try to measure the voltage across resistor. And for that, I will put it at the 20, like 20 volts thing. That is the maximum measurable value. So I think it will be, because it's 12 volts, so it should show the drop across the resistor 1K as a 12 volts. So this is the resistor I have. I'm like the voltage setting I will have, okay? So I will do that.
Do we have to take one of the 1.5 volt batteries out for the circuit, or this isn't a 1.5 volt and a 9 volt?
No, it's 3 volts and 9 volts. Okay, so I just mentioned before that it's 3 volts and 9 volts. Okay, and I'm trying to measure the voltage drop across the resistor by just checking the voltage across the resistor. Positive side and the positive, and negative side and the negative. How much drop you're seeing? I'm seeing 11.5. You are seeing the same? Across the resistor. I think I should take these pictures and I will post them, right? The pictures of the circuit, maybe. So I will post these pictures for you to look at this, okay? So is it clear? Can you measure the same voltage? Ulysses?
I have kind of a dumb question. Did you connect both 9-volt batteries or just the one?
One of them, yeah.
Okay. Give me One moment, sorry. Okay, yeah, okay.
Chris, Harshal, Nicholas, Maxwell, Benjamin, Nithya, are you able to do it? Sarab?
Yeah, I got a similar value.
What value you are getting, Nithya?
I got 11.6.
Okay, that's good.
Oh yeah, I got 12.6.
Okay. Okay, so we will record these values. Okay, and now we will measure the current. So I will take these batteries out and make the circuit for the current. So for the current, I need to again break it, okay, and make the measurements inside. So this is my positive side of the resistor. So I will break this circuit from here, put somewhere else. And similarly, previously, like I did 2 wires here and on the resistor leg. Okay. And I will connect the batteries again. Okay, sorry. I'll connect the batteries again. I'll take the picture. And I'll show you. Okay, let me check the current. So before checking the current, you need to move it to the current thing. You move it to 20 milli, 20 amp, where it is 20 amp. DC A, 20 amp, like here, like this, and try to see the current. So I'm getting to 11.6, something like that. So I feel those who are getting 12.6 should also getting more current, like 12.6 amps. So their resistor value will be 1K. Those who are seeing like 11.5, they are also seeing the current at 11.5 maybe. So mine is 11.6, okay? Am I clear about this thing? Okay, it seems we are clear, okay? Let me make sure I have the picture. I will post these pictures of the circuit on the canvas, okay? So that you can see that how we just verify that. Okay, so I am taking these batteries out. So we are done making them. Okay, so what I am trying to do is you need to measure the measured value of the resistors, okay? I am at the step 7. Okay, so you did 9-volt and 3-volt batteries in series. So you need to do voltage and current values for 3 volts, 9 volts, and 12 volts, which means that we have done first for the 3 volts, then we will be doing for the 9 volts. 9 volts means that you will just connect the battery, and then we will be doing for the 12 volts, like 3 volts and 9 volts will be connected in series. And then you will calculate the RM. And similarly for these 3 values, you will calculate the current. Just take care of the safety things like we did here. Just don't blow anything. Don't harm yourself and try to do this, okay? And then take RM out of the circuit and measure its resistance with your multimeter. And let's do that. So right now my circuit is not connected, okay? right now my circuit is not connected. I took it out, and maybe I take the wires out of that too. And I'll try to measure the resistance, okay? So for that, I will move it to the ohm value, 2000, okay? And let's check the resistance. So it doesn't matter whatever lead you have. So it's showing me 9, let's do it 20K maybe. So it's showing me 1.08. So that's the resistance value it's showing me, okay? And then whatever value you are looking at it, write it down, okay? And so the calculated value and the measured value need to see the difference. So the calculated
Professor,
yeah. Yes, Nicholas.
my battery packs are melting.
How? Why? You take it out?
I don't know. I did take it out.
What is melting? Can you share your screen? Some large current is flowing through it. Let me show you mine.
No, it started melting when it wasn't even plugged in.
Oh, really?
Yeah.
You were smelling the melting thing?
Yeah.
Oh. Did you connect it to, I can see that. Did you connect it to the circuit?
Yes.
And then it start melting, or it was melting before?
It melted after I removed it from the circuit.
Oh, because one thing can happen, okay? I'll show you. I just don't want to do this. So if you see these rails here, if you see these rails here, and if you connect these two wires, or somehow it may happen like that, that this is your power rail, and by mistake, if you connect it to some wire that is shorted with this power rail, right, then the battery will be shorted and this will be melted. So it can happen. That's why I was like that you should be very careful. So this thing, this black wire, somehow if it connects to this power rail or wherever this wire is connected, then it means it is a short circuit, okay? And then it can be melted. So you are not supposed to, I'm not sure what may happen, but you're not supposed to connect these two wires at the same level, okay? Because that will short them. Nicholas, you can check. I'm not sure how much is it, this thing and the battery. I think you need to get this thing only because you have another battery, right?
No, it was for the 1.5 volt batteries, the AA's.
It is for 1.5 volt battery?
Yeah, the cell batteries. That.
That was melted?
Yeah.
No, you showed me this thing. This is also melted?
No, this is the one that melted.
This is not melted, right? This is not melted. This is fine, right?
No, this is the one that's melted. This is fine.
Okay. Okay. So you need to get this and this. You have two more cells and two more batteries, I think. Right? You just need to get this holder.
Yeah.
Yeah. Okay. Yeah, just be careful next time. Maybe somehow this wire touches something that is at the same level. So it shorted out and it melts, okay?
Okay.
and take care of yourself too. Don't, in this remote scenario, it's hard, you know. Okay, so what is the error between the average of the calculated values and the measured values? That what you need to calculate as well. Average means that first you need to calculate separate errors, then you take the average of it, and then take the error as well. Okay, so I want you to draw a graph between I and V. So you have different values of voltages and you have different values of current. Draw the graph, and what will be the effect in the circuit if you replace your 1K resistor with the 10K? What will be the effect on the graph as well? Okay, you need to know that too. And yes, we tried swapping the terminals while measuring the current, and it was negative, right? So another thing we want to do today is checking the value of the resistors, okay? So if you can see in the resistors, let me shift my camera. If you see in the resistors, all the resistors have these color codes, right? Like the bands on them, right? So these bands, if you just pick this 1K resistor, okay? How you know that this is a 1K resistor, that you need to know, okay? So I'll just discuss an example and then you will see. So in this example, you can see that you have 4 bands. And what these bands represent, I will just show you. So if you move to the page, last page, in the last page, there is a table that you can see. So black, if this black is the first band, it has the 0 value. If it is a second band, it has a 0 value. Third band, it has a 0 value. So right now you are seeing a resistor that has the green band, and the green value you can see is a 5. Okay, so you will write 5 here. Then there is a blue band, and blue band has the 6 value. So that means 5, 6. And then yellow has the 4 value. So for this third band is the value of zeros. So what you should say here as well, the last color band is the number you will multiply by the results by. Match the third color band with the charge and the multiplier. This is the number you will multiply the other 2 numbers by. Write it next to the other 2 numbers with the multiplication sign before it. Okay, so let's say we saw 2 and then we saw 0, so we make 20, and the third color is yellow, which is 4, so it means that you need to multiply 20 into 10 raised to the power 4, right? So that's why you are getting 2200 kilo ohms here. So similarly, if I just take this value, so it was 56, and then I have to multiply 10 raised to the power 4 because this is 4. So it becomes 560 kilo ohms. Okay. Similarly, if you check this resistor, you can see this is a brown band, right? You can see a brown band, right? In the first, that is 1, right? Can you see 1K ohm resistor bands? So brown is first. So, okay, how you can say that from where it starts? So it starts where on the opposite side of the golden or the silver band. So this is the brown band, and then you have a black band. Black is 0, 1, 0, and then you have a red band. Red band is 2, means 10 raised to the power 2. So it means 1, 0, 100, which makes it 1K. Okay, now you need to see what tolerance you have. So gold has plus minus 5% tolerance, right? So it means that its value can change 1K plus minus 5%, which is a lot, right? That's why you are seeing such a difference in your voltages and currents, okay? Because your resistor value has a different tolerance, that is 5%. Am I clear about these things?
Yeah.
Okay, so then you have to fill this 2.1 and 2.3 table, but let me check another resistor, okay, with you. I am picking a resistor from 4.7K back, okay? Let's check it. So in this 4.7K, let's check that it's a 4.7K or not, okay? So its first band is yellow, which is 4. The second is violet, which is 7. Third is red, which makes it 0, 0. 10 to the power 2. So it makes it 4.7K. And the last band is golden, which makes it 5%. So it's again the 4.7K and it has the 5%. So you need to check the values of, and once you read the resistor, you can check it with your ohm meter too, okay? So that's how you need to know the resistors. So the third band is the multiplier, and the what you need to multiply is written here as well in the table. So you need to check with your digital multimeter, and you need to fill the tables with your in the 2.1 and 2.3. So you don't have all the resistors. Like in the 2.1, I think there are the values of the resistors. So just fill the table according to your values, so whatever values you have. So just write whatever the bands and whatever value you have, okay? Am I clear?
Yes.
Okay, so that's about it. So we have made 2 circuits. I just made very simple circuits. And for next time, I think what I will do is, for make it more easy, I'll post the pictures like I took today, so that it will be more easy for you to do it in the real time, okay? So you can try. I'm here. So if you want to try other values like 3, 9, and 12 volts, just be careful. Don't short them out. And I am actually posting the pictures, okay? Am I clear?
Yeah.
Okay, thank you. Let me just post these pictures with this lab, okay? Thank you. I'll turn off my video and I'm here if you have any questions.
Oh, I actually had a question about one of the circuits from lab 2.
Yes, go ahead.
It was the parallel circuit. I don't know, there was like a symbol. It was like the eye with the circle, and I wasn't sure whether or not that was like supposed to be some sort of current generator, or if that was just a way to express which way the current's supposed to flow in the circuit.
Okay, I know many of you have this question. Let me tell you, okay? Let me stop recording, then I tell you.